Okay, we're back in my shop again, and I'm not going to make you look at my ugly old face while I explain what happened. But we are standing in front of one of my prized possessions, is my old Clausing knee mill. But anyway, I got the video done, pushed it out to YouTube. Went very successfully, and when I looked at it, I had a typo in a couple things, and so I went back in to try to edit that out and failed miserably. And so I figured, well, so I just deleted the whole thing, and that went well. And then I edited what I needed to add in the original video, and I re-uploaded it, which took 45 minutes, and at the end of it, at 99%, it said this was an exact video of what I'd posted before, which, by the way, is not allowed. So I got online and looked everything up, and basically their answer was, hey, stupid, we told you you were deleting it and it would be gone, and you did it anyway. So if you make a mistake, I think you're just in trouble. So with that said, we'll get into just trying to add enough content to this video to let me get it back online. Good afternoon. I'm going to try to show you why I spent the time to try to figure out a good carriage micrometer indicator holder from my old Logan flat belt lathe. I've had 2 or 3 of these over the last 50 years. And due to their casting design, there's not a flat spot on them. Okay, so every time you go to put an indicator on them, you know, they just don't hold, they don't stick, they slide, they move. Now, A-Bomb 79, Adam Booth is my hero. Of course, he's got big equipment that in the table area here, there's lots of room between that and the carriage. Okay, and that allows him to just, you know, take a mag base like this and throw up here, and you know, you can run it over and boom, you're in. However, a lot of times this doesn't give me enough throw to work on the piece. And it's not a very big, this is less than a ½ inch right here to where it actually mags on. And I mean, it's real scoochy and it moves around. Okay, so that was number 2. The first one I tried to use was this, and this is actually something I've made probably 30 years ago. This is a copy of the normal carriage stop for Logan lathe, and you simply set it on like it normally went on, locked it down, and it worked great as long as you were working way out to the right. Okay, but of course what happened is you quickly ran out of, tool is still 2 or 3 inches away, and this is only a 1-inch travel. And you can't go any further to the left because of all the framework. Okay, so that one, that's kind of out. Then we took something like this. I've got a Noga and got a Char and got, you know, 2 or 3 different kinds. And that worked perfectly well. As you come over, you can see that I can pick it up. I can move it in and out. Everything is great. The problem is that, back to my first statement, there's not a straight casting on these lathes because of the draft process when they're casting the cast iron. So this thing just moves all over. No matter where you put it, it won't stay. All right. Now, so what I wanted was something like I keep seeing Adam use on his YouTube channel, is something magnetic that sets up over the way like this, and it sets on there and it's held by a magnet. And this is really very nice. It stays put. It allows you to come over. Okay, you can move it way back to the left, clear up into the pocket here. And the stem of the indicator misses this back here. So you can come up and actually that would crash the tool into the chuck right now, and I haven't even picked up on it. So it can also, of course, be reversed and put on that side by simply turning the indicator around. So with all that said, in fact, this is pretty tough. I'll lay it down because my hands heading towards 80 years old are very shaky. So let me stop this. Okay, so we'll first take a look at this thing all put together, and it's actually simple, but it's difficult to make, if that makes any sense. There's lots of angles, and one of the biggest problems with, if you make it just like the original Logan carriage stop, where everything is straightened to a 90, there's not clearance any place for the stem of your indicator to go out. So you have to drop it at an angle. So anyway, here's the back side, and this is machined out of a 1 by 2 inch block of aluminum. The first one I made, I usually make them out of plastic or starboard or whatever you want to call it. It's easy to machine. I actually only made it 1 inch, and that gave me only one magnet. That was just not enough. Too much leverage, and it moved around. Okay, there's one button head that holds it on, and I used a spacer washer only because the post on the back of this dial indicator is not perfectly straight. So here's a picture of the whole thing. This is simply JB weld to fill up behind the magnets, and I used some of this Loctite 620 to fasten the magnets in. And when in a minute I'll go over how I did it on the milling machine, and really, if you're it gets a little confusing with all the compound angles and the clearances. So anyway, let's take you over to the milling machine, and I'll show you how I had it set up. Alright, now don't forget this is filler, and my neighbor told me I needed to display these dimensions and that better anyway, but so anyway, here we go. Okay, so we're starting with a 1 inch by 2 by 2 block of aluminum, or whatever material you decide to use. And here's our 25-degree angle block. We simply set it in, position it high enough to when you're cutting it, your milling machine cutter does not hit. Okay, now we're going to actually, I'm not sure what's going to happen with all the foaming, but we might even move off frame. But we're going to start over here and bring this side of the cutter down to this edge. And then we're going to move over exactly 1 inch. And for this demo, I'm not going to try to read my readouts because they're too hard to get to. So anyway, this places the right side of that cutter on a 1/2 inch end mill where it should be, leaving about 750 thousandths to the right of the cut. Now, by the way, make sure you don't make this cut any wider than a 1/2 inch. In fact, this is an end mill that has been reground, so it's a little bit less. So then you simply start your cut and plunge down 50 thousandths, a 1/2 inch So you're going to end up with a slot milled through here, 3/4 of an inch in, 50 thousandths inch deep, and the full width. And you're going to do it with a 25-degree angle block with the high side of the block under the right. All right, let's do take the first step here, and I'm not going to actually machine a whole one of these because it's really a lot of trouble. But what I found out, to get the correct clearance and the tilt you need on the face of the gauge to where you can actually read it easily and make everything miss all the castings and etc., is I use a 25-degree gauge block. All right, simply set it in. And this piece of starboard's not quite big enough, but it's going to turn out okay. So anyway, set it in the long way, and if you happen to have two of the 25-degree angle blocks, it's a lot easier. But with this, what I do is set it in, make sure you got enough clearance all the way around. Just snug it up, and then don't beat it hard, but take you a brass hammer or something and tap the back of the angle block, and it'll square it right up to the bottom for you. Then go ahead and lock it down. All right, now you're through with this for a minute. Now the first cut we're going to make is actually this cut right here. Okay? So what we're going to do is we're going to take the far right hand side, in this case, of the 1/2 inch cutter, and we're going to touch off. This I'm going to have to make it a little bit different than this one because the material was not quite the same width. But anyway, I'm going to bring it over like so and come down. Start the mill. I guess it'd be better to have it running the right direction. I was tapping with it. Okay, so there we're just barely scratching it. I'm going to come back out here. Now I'm going to stop the camera for a minute. We're going to actually go down a 1/2 inch total. So everything is a 1/2 inch, a 1/2 inch, a 1/2 inch. Okay, my first cut was 300 thousandths deep, and I'm going to take the last 200. I'm running this slow because this plastic had a tendency to melt, or at least get sticky. All right, now that was step one, that you're going to use this 25-degree parallel on. Slide it up. Okay, now the next one, believe it or not, you're going to reverse it after a while, and you're going to turn this whole piece around, and you're going to use that same one to drill the magnet holes. Now I selected 1/2 inch magnets. Alright, and so actually you set the same angle block in like so, and you end up with this nice and level. Simply drill the 1/2 inch holes. I actually just used the end mill, I do suggest that you make them loose, though. Don't do like I did, using the aluminum block and those hardened magnets. When I used the Loctite to put them in, I ended up driving them in and didn't get them as level as I wanted to. So anyway, make those holes a little loose. All right, and then the last time you'll use this 25 is after you get the 90-degree V cut in here. You set it back in here and you cut this angle right here. So you're going to use this 25-degree angle block 3 different times. All right, let me get set up for the next thing. So here we go again. We're now using 2 angle blocks, a 15 and a 3, for a total of 18 degrees. This time we're going to set the high side on the left. All right, and I'm going to use a workpiece I've already done before and simply show you that we're setting it up and tap it with a hammer to get it straight. And what we're actually trying to do is mill this bottom here flat, and when you mill this flat here, and this side automatically becomes 90 degrees to it, and that's actually your V. So we used a wiggler in here to line up on this side, and then simply move the 1/2 inch bit 250 thousandths to the left, or move the workpiece to the right, and then use that 1/2 inch cutter and you mill down until the bottom of this part you're working on now just kisses the corner of this side. Thank you. Okay, so what I've done here is use my little stirret wiggler to find the exact edge of this junction down here from the milling machine bit. And what we're going to actually do then is move this block over 250 thousandths this way, which will center that same 1/2 inch milling machine cutter to make the next cut. All right, what I've done is removed the wiggler, put in a 1/2 inch collet in my 1/2 inch bit, and I've moved the table to the right 250 thousandths. In the idea, we want this far right hand side of the milling machine cutter to end up right here in this groove. Okay, so here we go. Gonna make it in a couple cuts. And by the way, I apologize for not letting you know the angle of this, but it's about 18 degrees. So these 2 blocks put together, angle blocks, give me 18 degrees. It was rocking between 18 and 19, and really for what it's for, I guess it's truly not that important. All right, and clean out some of the chips here. Believe me, this really all looks weird when you're trying to lay it out. We got about 4 or 5 thousandths to go yet. So that's actually up in here. This is the 90 degree that sets on the way of your mill. I mean the bed of your your bed of your lathe, I'm sorry. All right, one other thing we're going to do in a minute is we're going to take a little 3/16 milling machine cutter, and we're going to cut a bit of a relief here and a bit of relief here. I found it makes life a little bit easier. Okay, I'll get set up for the next one. Alright, if you remember when I first started the first cut, we used this 25 degree angle block, and we made this cut here 1/2 inch deep. Okay, then we used the other 2 blocks combined to make this actual cut down here, the 90 degree in the bottom. And I told you we'd be using this angle block a couple more times. Well, this is the second time, and we're just cutting the top edge of this off so there's clearance on the bed of the lathe on the flat part on the front V-way. So here we go. Alright, I'll get set up for the next cut. Alright, actually, it's easiest to do the plunge cuts for the magnets just to line up this cut here with the top of your vise. It's not critical, it just lets the magnet meet with one of the 45s on your lathe way. So I've come in, I used the old paper trick to get close to this edge within 1/1000th or so, and I come in and we'll leave 1/4 of an inch at the back, then we'll come over and leave 1/4 of an inch on this side, and hopefully I can do this. I think I'm just going to raise the table. That way I can stay out of the picture a little. Now, drill all the way through. You can, on the back side of mine, you saw where I used JB Weld to fill it up. That way, if you have a problem, you can fix it. Now, I thought it might be necessary to put additional magnets on here, but trust me, 2 of them holds like freight car. Okay, I'll be back in a minute. Okay, what we've done is I took my indicator and set it on here like you would really want it. Because I've checked a couple indicators, they're not all exactly the same size as far as the depth of the hole on the mount. So I drilled it 5/8 of an inch deep with a number 7 bit. This is a 1/4 20 tap, and we're just going to go down a ways. Going to slow the mill way down. There's a 1/4. There's a 1/2. That's about it. Reverse the mill, back it out. I put this permanent magnet 1-horse DC motor and a control on here, oh, years ago. Best thing I ever did. Makes life really easy. Now off camera, I'm going to go ahead and run a bottom tap down to get the most clearance I can. See you in a bit. Okay, so now the part's pretty well done. I don't know how well you can see that. The angle's all cut. Holes drilled for the magnets. Drilled and tapped to attach the dial indicator. So I'll go ahead and clean it up, mount the indicator. The only thing I won't do is put the magnets in it because I don't really plan on using it. Alright, so here's the part we just made. Indicator mounted. Sits right up there. The 2 magnets will hold it securely in place just like it did on the aluminum one. And there we have something we can move any place we want. Whoops. No matter what length material we're working on, it'll move all the way back up here in the pocket, which actually would, if you tried to contact the indicator, you would the cutter would crash into the chuck up here. So you get plenty of clearance. I guess you could actually run it with a collet chuck and maybe use the full capabilities. All right, hope you enjoyed the video. I'll try to draw up some pictures with the angles and etc. on it. Later. All right, to wrap up this video, here's a drawing, and I'll leave it here for a bit. And the outside dimensions, of course, this is taking a look at the end of it. Okay. And the important part is that this V right up here, this is a 90, and that fits on the way of your lathe, the bed. And this is the same 90-degree V right here. That shows you this is a 90. These are the other degrees, and you know, like I told you before, to get these, you know, your first cut, here's your milling machine cutter coming in this direction. This is standing straight up. You place a 25-degree angle block under it, make that cut down exactly 1/2 inch. All right, then you turn it this way, and this cut, you line up your milling machine bit where the outside edge is just on the corner of this, and I used a wiggler. Then you move it over 250 thousandths, and then you machine this the same thing, straight down with 1/2 inch to where these two corners meet. All right. Here I'm trying to show you that one of the degrees, this is 28 degrees here, what you end up with. So from the bottom straight edge, the only two straight edges on this thing when you're done are here and here. So from here to here it's 28 degrees. Coming across here, this is 25 degrees. So you lay your block here and face it down, it's 25. So I hope this is clear as mud to you, but your overall dimensions, this shows 1/7/8. It was because the piece of material I had been machined a little bit already. Could be at 2 inches. The length of the item, so this end you're looking at the width, this end you're looking at the width, the length. Can be anything you want. About 2 inches was fine. This hole right here with the dotted lines, the dashed lines, shows you that while you're setting in this operation with your milling machine cutter this way, cut your slots and then turn right around and drill the magnet holes. Like I said, I used 1/2 inch diameter. They're about 3/8 thick and they're really quite strong. Drill those holes all the way through. So this represents a through hole. Make it big enough so when you put the magnets in the block, okay, put your whatever you're going to use to fasten them, like I said, I use Loctite, and then simply set it, grease your bedway, the V, the front portion, and set that on your lathe bed. That will pull the magnets in tight. The grease or oil will keep the Loctite from sticking it to your lathe, and then just put pressure down and hold it in place. Let it dry overnight. That is a surefire way to get perfect contact with the magnets to the V on your lathe, on your way. So with that said, hopefully you can get some use out of this. Anyway, I love it. It's the only thing I've found in 40 years of messing around with Logan lathes that will fit up into the pocket, lay down at a nice angle to where you can read it. You can simply move your dial any place you want, and like I said before, you can reverse this and put it on the tailstock into your lathe if you want to work it that direction. Thank you much for watching. Have a great day.